Note that if I use direct substitution in here, I'm going to get 8 times 5 is 40 minus 1 is 39 over 5 minus 5 is 0. That tells me right away I'm taking the limit at a vertical asymptote. So it's 5. You notice this is a one-sided limit. It's 5, but a little bit more. So why not use 5.001? 8 times 5.001 minus 1 over 5 minus 5.001. When do I use this technique? I recognize I'm looking at a vertical asymptote and I'm taking a one-sided limit at the vertical asymptote. Well, this is going to give me a positive number divided by a negative number. So our graph is going to be heading towards negative infinity. And in fact, when we look at this graph, and I'm not expecting you to do this, but we're going to have something that looks like this. Our graph goes down, 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 and up, up, up. So as x approaches 5 from the right, we can see that our graph goes down, down, down. A one-sided limit at a vertical asymptote, if this is a vertical asymptote, our graph is always going to be either going up and down, up towards positive infinity, or down towards negative infinity, or up and up, or down and down. Notice that was the one-sided limit, negative infinity. If I gave you limit as x approaches 5, the two-sided limit, that's the one you'd say does not exist because we have no trend in y here. But we can find the trend in y with a one-sided limit at a vertical asymptote. And the technique I use is to just substitute in a value very close to the desired value. If I'm asking for this one-sided limit, so important for us to realize it's a one-sided limit. Well, if I use direct substitution, I have 2 plus 1 over 1 minus 1 gives me 3 over 0. That direct substitution results in a number over 0. So I know I'm dealing with a vertical asymptote. So I'm going to pick a number just a little bit bigger than 1, 1.001, and 1 minus 1.001. Of course, that will give me a positive numerator divided by a negative denominator. Because this is negative, I'm going to say my graph is going towards negative infinity. If I were to graph this, I have a vertical asymptote and a horizontal asymptote, and my graph actually looks like this. It's going up, 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 and down, down, down. So you can see as x approaches 1 from the right-hand side, the graph is in fact going to negative infinity. I just want you to connect that. We're not just finding numbers here. That's what's happening. As we squeeze in on x equals 1 from the right-hand side, our graph is going down, down, down towards negative infinity. And we're finding that trend in y. We can find the trend from the right. It's a one-sided limit. If I ask you the limit as x approaches 1, if I gave you a two-sided limit, here you'd have to say the limit does not exist because we have this infinite discontinuity there. Don't forget that our biggest and most important technique is direct substitution. This is a two-sided limit. Look, there's no 3 positive or 3 negative. So if we make this substitution, we get 3 minus 2 over 3 squared, which is 1/9. There is our limit. As x approaches 3, y is approaching 1/9. And here, in fact, is the graph of this. Note, bottom heavy, y equals 0 is our horizontal asymptote. Set your denominator equal to 0. We get x squared equals 0, so x equals 0. X equals 0 is our vertical asymptote. Y equals 0 is our horizontal asymptote. And we get this point, 3 1/9, because look at, as x approaches 3, y is approaching 1/9. That's the trend in y, of course. So if we are looking at this problem, of course, what we want to do, even though this is let's recognize this is a one-sided limit. It's a one-sided limit. Does not matter. We're going to make the substitution and we get 0 over 0. So you kind of have to be a detective and realize that this is a whole. And so we're not going to use that technique. So there's no going 0.49999 or 0.500001 here because it's a whole. We only use that technique at a vertical asymptote. So our technique here will be as what we've always done. Even though it's a one-sided limit, we're going to try to factor, and this factors into 3x minus 1 times 2x plus 1. And then on the bottom, we get 2x plus 1 times 2x minus 3. Good thing I've had years of factoring. So 3x minus 1 over 2x minus 3 is our surviving function, and 2x plus 1 equals 0, 2x equals negative 1, x equals negative 1/2. Of course, we knew that was going to be the x-coordinate of the whole. So now that we have that, let's use direct substitution and substitute into our surviving function. 3 times negative 1/2 minus 1 over 2 times negative 1/2 minus 3. Notice, even though the limit was a one-sided limit, because it's a whole, I don't have to go a little to the left and a little to the right. I can just use the x value of the whole to find out. We get 5/8 here. Now that is the limit, and the bonus is, where's the whole? As x heads towards negative 1/2, y is trending towards 5/8. There is the whole. But remember, the y value of the whole is the limit. It's the trend in y. Remember, my first and best method, my first line of defense is to substitute. I recognize that this is a one-sided limit. We're approaching positive 3 from the right. But look what I do. I'm just using 3. And when I do this, I get 3 over 0. What's that? Of course, I know that I'm dealing with a limit at a vertical asymptote. So this is where I say this is 6 minus x over the square root of x minus 3. If it's 3, but a little positive, this is where I do 3.001 and 3.001. Notice I'm going to get a positive numerator, and this is a slightly positive, square root is slightly positive. So my graph is heading towards positive infinity. We just found out that the limit as x approaches 3 from the right is positive infinity. This is what the graph of this looks like. You can see as x squeezes on 3 from the right, the y value is heading up, up, up to positive infinity.